Welcome to qnawire.
The only thing we have to do to solve this question is solve that integral. So remember that the ground state wave function psi100 is equals to this one. Then substituting this result in the integral, we get this is equals to 4 pi to the outside times the integral from 0 to infinity of r cubed times this squared, which is pi r0 cubed under e2 minus r0 times 2, because it's squared, and this integral is over r, then dr. This is equals to 4 pi divided by pi, this factor out, times the integral from 0 to infinity of r divided by r0 cubed times e to minus 2 times r divided by r0, and this integral is over dr. This is very suggestive, as we can now use the following substitution. U is equals to 2 times r divided by r0. Then we get du is equals to 2 over r0 dr. So dr is equals to r0 divided by 2 times du. Then the integral is 4 times the integral from, when r is equals to infinity, u is also equals to infinity. R divided by r0 cubed is nothing else than u divided by 2 cubed times z to minus 2 times r over r0, which is just u. Now we have dr, which is r0 divided by 2 du. Putting these factors outside and this factor of 2 to the cube outside, we have 4 times r0 divided by 2 times 1 divided by 8, 2 to the cube, times the integral from 0 to infinity of u to the third times z to the minus u du, and this is equals to r0 over 4 times the integral from 0 to infinity of u to the cube e to the minus u du. Now we stop here for a brief moment to look at some cool result, which is, let's define a special function I alpha by the integral from 0 to infinity dx of e to the minus alpha x. This integral is very simple to solve. This is equals to e to the minus alpha x under minus alpha from 0 to infinity, which is equals to 1 over alpha. When we plug in x equals to infinity, we have e to the minus alpha times the infinity, and e to minus infinity is equals to 0, so we don't have this term. When we plug 0, we have 1 over minus alpha, but this is the next limit, so we have 1 minus 1 over minus alpha, which is 1 over plus alpha. Then, from one hand, I alpha is equals to alpha to minus 1. But note that dy alpha over d alpha, by definition, is equals to the integral from 0 to infinity of dx minus x, taking the derivative with respect to alpha of this function, times z to minus alpha x. So, note the following. Taking the derivative of y I alpha results in an extra term of minus x here. So, our integral is just the third derivative of I1. Then all we have to do is derive this result 3 times and substitute in our previous situation. So deriving once, we get dy alpha over d alpha is equals to minus alpha to minus 2. Deriving twice, we get minus 1 times minus 2 times alpha to minus 3. And deriving one more time, we get minus 1 times minus 2 times minus 3 times alpha to the minus 4. Oh, and also forgot something here. By deriving 3 times, we will get an extra minus sign on the outside, which is undesired here. So what we need is minus the third derivative. The third derivative is equals to minus 6 over alpha to the 4th. Then minus the third derivative when alpha is equals to 1 is equals to 6. Simple 6. Then r bar is equals to r0 divided by 4 times 6. And then we get r bar is equals to 3 r0 divided by 2.